Hi guys, so in the first part of the tutorial series we set up this little player guy who could jump around and be constrained by collisions above and below him. So in this part we're just going to be making him be constrained by collisions to the left and right of him, and also making the camera follow him around, and then in the next part we're going to be adding in a proper character with animations and that sort of thing. So let's go into MonoDevelop, and before we start on the left and right collisions, there are a few improvements that I want to make to this up and down collisions that we set up the last time. So the first thing is just that over here we're adding the skins width variable regardless of whether the player is moving up or down. We actually want to add or subtract it based on the direction. So we're going to subtract it multiplied by the direction. And the other thing is over here where we've set the length of the ray to be the same as the amount being moved in the y direction. I also want to add the skins width variable over there just to make sure that it never glitches through the ground or something like that. So now let's copy this whole block of code, and we can reuse this for the left and right collisions. Okay, so first thing we need to do is just change all the instances of delta y to delta x. So just press Command F and replace with delta x, and we can just replace each of these here. And now we want to change where the ray is being cast from. So for the y direction, we want that to be at the player's y direction plus the center of the collider dot y minus the size dot y over 2 of the collider. So that will put it right at the bottom, and then we'll be adding size dot y over 2 multiplied by I, so that it will start off at the bottom, then at the center, and then at the top. Okay, and then for the x direction, we want this to be at the player's x position plus the center of the collider dot x plus the size dot x over 2 of the collider multiplied by the direction. So that will just put the ray at the left or right edge of the collider based on the direction. Okay, and now another thing we want to change is here where we've set up the ray. Over here we have the direction of the ray, and for the x value we want to have the direction, and for the y value we'll just put in 0. And since this grounded equals false only pertains to the vertical collisions, we can just delete that. Now let's go into Unity. Where is Unity? Over here. And we can just create a little block to test with. And let's see if this is working. And it is. You can see the player is being constrained to the collisions over here. So the only problem that you might notice is that if you slide into it and then you immediately try and move away, it appears as if the player is actually sticking to the cube. And the reason for that is just that if you look over here, you can see we've got the sort of natural sliding that occurs, but the acceleration is not being reset when you hit into the block. So you're not immediately moving away when you try change direction, which gives this sort of sticky feeling, which isn't good. So the way we're going to stop that is we're going to create a variable here next to the grounded, and we can just call this something like movement stopped. And now where the grounded variables were being set, we're going to say here, similarly, movement stopped equals false. And then if there was a collision, movement stopped equals true. So that's just inside this raycast block. And now going into the player controller, we will we'll have a statement like if player physics.grounded is true, we'll say if player physics.movement stopped, then we can just say that the target speed is equal to 0 and the current speed is equal to 0, so that will reset all acceleration. But make sure that this comes before we have this whole block of code doing the input, because you don't want to never be able to start again once you collide with something. So let me just verify that this is working correctly. And it is. You can see you can instantly change direction after colliding with something. Okay, so that's all our collisions done for the time being. Let's move on to making the camera track the player. So we're going to create two new scripts here, actually. The one's going to be called Game Manager, and I'll explain what that's all about in a moment. And the other one is going to be Game Camera, and we're going to assign both of these to the main camera. Yes, you can save. Okay, so what the game manager is going to do is it's going to handle a whole bunch of stuff, but for now it's just going to worry about instantiating the player when it spawns. So later on we'll also do stuff like checkpoints and all that sort of thing. But for now it's just going to have one method, a private void called spawn player. And in its start method, the spawn player method is going to be called. And it's going to have a public game object, player. And over here it's going to say instantiate player at, you can just say vector3.0 at, well, quaternion identity, which just means 0 rotation. And now we're going to create a prefabs folder, and in here we're going to drag our player object, and now we're going to safely delete our player because it's stored here. And in the main camera we're going to drag this prefab object onto the player. So now at the beginning, the player should be instantiated. And now the game camera is going to have a public void called setTarget. And this is going to take in a transform t. And it's also going to have a private transform called target. And what we're going to do in the game manager is we're also going to have a reference to this game camera script. Just call that cam. And in the start method we're going to be getting a reference to that game camera. So cam is equal to get component, because they're on the same object, of type game camera. Okay, and now we want the player to be the camera's target, so we're going to say cam.setTarget, and we want to pass in this object that we're instantiating, the player, except it takes in a transform. So here we're going to say as game object. We're going to put all of that in brackets. As game object dot transform. Okay, now we can go into the game camera, and in the setTarget we can just say target is equal to t. Okay, simple as that. Now we want to have a void late update. So late update is kind of the same as the update method, except that it happens after all the update methods. So we just want to make sure that the follow code only gets executed once the player's moved. That's why we're putting it in late update. Okay, so the first thing we want to consider is that in some cases the target might actually not have a value assigned to it. For example, if the player dies, then this would become null. So we want to make sure we don't get a null reference exception thrown. So we're going to say if target, which is the same thing as saying if target is not equal to null, basically. But we can leave all of that out. We can just say if target. Then we want to increment the camera's position towards the target's position. So we're going to go into the player controller, and we're just going to copy this whole block of code that we set up in the first part called increment towards, because that's exactly what we want the camera to do. And now we can just say float x is equal to increment towards. So we're starting at the camera's current x position, so transform.position.x, and we want to increment towards the target's the target's x position, target.position.x. And for the acceleration, we can just have track speed, which we have to set up. So over here we can just say private float track speed. You can make that public if you like to mess around with things in the inspector. I prefer to change it in the code, but that's all up to personal preference. And you can just set this to something like 10. You can mess around with that value. And now exactly the same thing for y. We just replace all these x's with y's. And now we can say transform.position is equal to a new vector 3, and for the x, x, and for the y, y. And for the z, well, we don't actually want the camera to move at all in the z direction, so we'll just say transform.position.z, so it just stays at its own z direction. Okay, let's see how that's working. Okay, so we're getting a null reference exception here. That is fine. We must just see what the cause of that is. So, okay, so simply our order of events here, we said spawn the player, and then we told the code what camera is actually equal to. So obviously we want to set that first, and then spawn the player. Okay, that was just a little oversight on my part, sorry about that. And now, okay, so it looks like we've got the wrong values mapped here, so let's quickly jump into the game camera and see. Yeah, so it's incrementing towards the target.position.x, so I just missed one out there. Just change that to y, and now I believe everything should finally be working. Hooray, that is working as I want it. So yeah, that is everything that's going to be covered in this part. Next part we will, as I said, just do some cool stuff with the animations and that sort of thing. Start getting this looking less prototypey and more like a proper game. So yeah, until then, cheers.